Number 12, approximately what is the smallest detail observable with a microscope that uses ultraviolet light of frequency 1.2 times 10 to the 15th hertz? So basically the smallest detail would be equal to its wavelength, all right, the wavelength. That would be the smallest detail. So in other words, we need a formula that relates frequency to the wavelength. We've seen this now, right, that the speed of that wave will equal then the frequency of the wave multiplied by its wavelength. So here, if we're trying to calculate wavelength, you got to divide both sides by f. So the speed now, we've seen this plenty of times, it's going to be the speed of light, right? Because we're assuming that it's traveling basically in a vacuum or air, they're very, very close. And divide that by the frequency of 1.2 times 10 to the 15th hertz. And let's calculate. So there's going to be 3 times 10 to the 8 divided by 1.2 times 10 to the 15th. Okay? So this works out to be a wavelength of 2.5 times 10 to the minus 7th meters, all right? So that works out to be about, what is that, 250 nanometers or so? So that's that, all right? That's the smallest detail. Guys, thanks so much for tuning in. I appreciate it, and I'll see you in the next one. Take it easy.